Everyone, welcome back to my YouTube channel. My name is Lakshmi, a student of Sri Venkateshwara College of Engineering in the Department of Computer Science and Engineering Data Science. In this video, we will be discussing about the subject Introduction to Mechanical Engineering. The subject code is BSCK204D. The contents we are going to discuss in this video are heat engine, introduction to IC, 4-stroke petrol engine and 4-stroke diesel engine. Now let's move on to the heat engine. Heat engine, it is a machine for converting a heat developed by burning fuel into the useful work. It can be said that a heat engine is equipment which generates the thermal energy and transfer it into the mechanical energy. Heat engine can be broadly classified into two categories. The first one is internal combustion engine. The examples are steam engine, steam turbine, closed cycle, gas turbine, etc. The internal combustion engine, that is IC engine, example is petrol engine, diesel engine, gas engine. The IC engines are performed because of high efficiency, simplicity, compactness, lightweight, easy starting, comparatively low cost. Introduction to IC. The internal combustion engine, it is a heat engine that converts the chemical energy into a fuel, of a fuel into a mechanical energy. In this diagrammic representation, you can observe that the engine is being given and the chemical energy converted into heat, as well as it is converted into mechanical energy. Now let's move on to the next topic. Based on the stroke of the IC engine, it is being classified into two types, that is 4-stroke engine and the 2-stroke engine, 4-stroke. In this type of engines, the working cycle is completed for the 4 different stroke. 2-stroke engine, in this type of engine, the working cycle is completed in the 2 different strokes. The 4-stroke petrol engine, here is the representation that how the 4-stroke petrol engine works, and the PV diagram has been plotted, that is pressure versus volume graph has been plotted. Now let's move on to the topic. The working principle of a 4-stroke petrol engine, that is based on the theoretical Otto cycle, that is constant volume cycle. Hence it is also known as the Otto cycle engine. The 4-stroke engine's pistons that perform 4 different strokes to complete all the operations of the working cycle. The 4 different strokes that performed are suction stroke, compression stroke, power stroke, and the last one is exhaust stroke. The suction stroke. This suction stroke that starts when the piston is at a TDC and about to move downwards. During this cycle, the inlet valve remains open and the exhaust remains closed. Due to low pressure created by the downward moving of the piston, the charges, that is air fuel mixture, is drawn into the cylinder. At the end of the strokes, the inlet valve closes. The suction stroke is represented by the line AB on the PV diagram as shown in the figure. The second one is a compression stroke. During this stroke, the compression of a fresh draw charges takes place by the return stroke, that is BDC to TDC of piston. During this stroke, both the inlet and the exhaust valves are closed. As the piston moves upward, the air petrol mixture in the cylinder is composed adiabatically. The pressure and the temperature of a charges increases, and this is shown by the curve BC on the PV diagram. When the piston reaches the TDC or just before the completion of the compression stroke, the spark plug ignites the charges. The combustion of the fuel takes place at a constant volume and is shown by the line CD on the PV diagram. The compression ratio in the petrol engine ranges from 7:1 to 11:1. The next one is a power or expansion stroke. At the beginning of a stroke, piston is at a TDC, and during the stroke, the piston move from TDC to BDC. During this stroke, both the inlet and the exhaust valves remains closed. The combustion of a fuel that liberates the gases, and these gases starts expanding. Due to the expansion, the hot gases exert a large force on the piston, and as a result, the piston is pushed from TDC to BDC. The power impulse is transmitted down through the piston to the crankshaft through the connecting rod. This causes a crankshaft to rotate at a high speed. Thus, work is obtained in the stroke. Hence, this stroke is also called as a working stroke. Also, gas expands and does work on the piston. So, this stroke is also called as an expansion stroke. The expansion of a gases is adiabatic in nature, and this is shown by the curve DE on the PV diagram. As the piston reaches the BDC, the exhaust valve opens. A part of a burned gases escapes through the exhaust valve out of the cylinder due to their own expansion. Expansion stroke. At the beginning of the stroke, the piston is in the BDC, and during this stroke, the piston moves from BDC to TDC. During this stroke, the inlet valve is closed and exhaust valve is opened. As the piston moves upward, it forces the remaining burned gases out of the cylinder to the atmosphere through the exhaust valve. This is shown by the line E, B, and BA on the PV diagrams. When the piston reaches the TDC, the exhaust valve closes and the complete the cycle. In this next cycle, the piston which is at a TDC that move towards the BDC, thereby allowing the fresh charges to enter the cylinder, and the process continues. Now let's move on to the four-stroke diesel engine. Here is the graphical representation, that is PV graph has been plotted for the, and here is a diagram how the strokes will be working. The working of a four-stroke diesel engine that is based on the theoretical diesel cycle, hence it is also known as a diesel cycle engine. That is suction stroke, compression, power, as well as exhaust stroke will be present in this. The suction stroke, at the beginning of the stroke, the piston is in the TDC, and during this stroke, the piston move from TDC to BDC. During this stroke, the inlet valve opens and the exhaust valve will be closed. The downward movement of a piston creates a suction in the cylinder, and as a result, the fresh air is drawn into the cylinder through the inlet valve. When the piston reaches the BDC, the suction stroke completes, and this is represented by the line AV on the PV diagram. The next one is a compression stroke. At the beginning of the stroke, the piston is in the BDC, and during the stroke, the piston move from BDC to TDC. During this stroke, the both inlet and exhaust valves are closed. As the piston moves upward, air in the cylinder is composed of a high pressure and a temperature. The compression process is adiabatic in nature and is shown by the curve VC in the PV diagram. At the end of the stroke, the fuel, that is diesel, is sprayed into the cylinder by fuel injector. As the fuel comes into the contact with the hot compressed air, it get ignited and undergo combustion at the constant pressure. This process is being shown by the line CD on the PV diagram. The compression ratio is in the range of 16:1 to 20:1. This is the representation for the expansion and exhaust strokes. Now the exhaust or expansion power or expansion stroke. At the beginning of the stroke, the piston will be at TDC, and during this stroke, the piston move from TDC to BDC. During this stroke, both the inlet and exhaust valve will be remain closed. As the combustion of a fuel takes place, the burn gases expands and exerts a large force on the piston. Due to this, the piston is pushed from TDC to BDC. The power impulse is transmitted down through the piston to the crankshaft through the connecting rod. This causes the crankshaft to rotate at a high speed, thus the work is obtained in this stroke. The expansion of the gases is adiabatic in nature, and this is shown by the curve DE on the PV diagram. When the piston reaches the BDC, the exhaust valve opens. A part of a burn gases escapes through the exhaust valve out of the cylinder due to self-expansion. The drop in the pressure at a constant volume is shown by the line EB on the PV diagram. Exhaust stroke. At the beginning of the stroke, the piston is in the BDC, and during this stroke, the piston moves from BDC to TDC. During this stroke, the inlet valve is closed and exhaust valve is open. As the piston moves from upward, it forces the remaining burn gas out of the cylinder through the exhaust valve. This is shown by the line BA on the PV diagram. When the piston reaches the TDC, the exhaust valve closes, the completes the cycle. In the next cycle, the piston which is at a TDC that move towards the BDC, thereby allowing the fresh air to enter into the cylinder, and the process again continues. That's all about my presentation. Please do like the video.